Hey everyone, welcome back to the DevOps Lab. On this episode of the DevOps Lab, talking about on-prem to the cloud, Jessica Dean is going to walk us through moving towards a bit more of a cloud native scenario with containers. It's very cool stuff and easier than you think. Don't miss it. Hey everyone, welcome back to the DevOps Lab. I'm Damien Brady and I'm joined today by Jessica Dean, and we are going to be talking about the next stage of our on-prem to the cloud series, where we're going to be talking a little bit more about our next journey to the cloud native. So first off, welcome, Jessica.
Thank you. Thank you for having me. It's always great to hang out.
It is, yes, and rarer these days than it used to be, but really good to have you here. So the last couple of episodes, we focused on moving our on-prem application and the database from our on-prem server onto the cloud. Yeah. But we want to kind of take it a little bit further and move a little bit closer to this cloud native scenario. And so you're going to take us through containers, correct?
I am. And with containers, a lot of times people hear containers and think, great, we're going to go ahead and jump into Kubernetes and we're going to have this all locked down and we're going to be ready to go full steam ahead. And to that, I say no. There's definitely a on-ramp period, and there's the easy way, and then there's the better way. And we're going to kind of walk through that today.
Okay, so first up, before we get started, can you talk to us why it's a good idea to move to containers, or why we would think about doing that in a general sense anyway?
Absolutely. The first reason is virtual machines are expensive, both from a time perspective and a size perspective, right? I mean, just a Windows 10 virtual machine without any additional software is going to be around 20 gigabytes and is only going to get larger. And they're slow to start up. They're very hard and convoluted to manage. And a lot of times what you need to run your application, for example, this application, which is ASP.NET, is you really only need access to IIS and you need access to ASP.NET, both the SDK to build your application and then also runtime. But those are the only processes that you actually need to serve your application to your end users. And when you kind of take those processes and put them into an isolated environment or a container, now you reduce your footprint. And you can do that with Windows, and you can also do that with Linux containers. And so we'll talk about the pros and cons of both scenarios.
Okay. So Jess, when we looked at the last moving our app service onto platform as a service, we got rid of our virtual machine. And so platform as a service is another option. Is containers kind of another advantage, or does it have other advantages on top of platform as a service?
Yeah, so actually app service, which is where our application is currently hosted, allows you to serve just your normal zip file, right? But you can also do containers. You can do either Linux or Windows. And one of the benefits of a container is it's an encapsulated runtime environment. So it doesn't matter if I run it on my local system or if I put it over into Azure, whether that be Azure App Service. We also have Azure Container Instances, which is kind of like Docker Run in the cloud. And then we also have, of course, Kubernetes. But the nice thing is containers will work the same way no matter where you put them. And the benefit to this is, I think we've all been there, where we've all heard it works on my machine, and then somebody else tries to run it on their machine and tries to compile it, and they have a mismatched version of ASP.NET or Node or Java, and now they're starting to have issues with running the application, building the application, and the confidence containers gives you is that it's going to run and build the same way every time, no matter which environment it's in.
Yeah, that's awesome. Definitely a benefit. I've had that scenario plenty of times before, the one you mentioned. So how about we jump into it? Can you show us what it looks like? You mentioned there's an easy way and a more detailed or a better way of doing it.
Absolutely.
Why don't we start with the easy one? Yeah.
Yeah, so I'm going to go ahead and go over here to a Windows machine I have. Now I'm within Visual Studio 2019. And the nice thing is this application previously did not have any container support. Now, first, let's go ahead and make sure we define what a container is. A container is not actually a real thing, okay? Now, bear with me here. It's not a real thing. It's nothing that's tangible. Instead, it's an application delivery mechanism with process isolation. Its only goal is to deliver that application with the processes that you need to serve that. So within Visual Studio 2019, there's a few different ways that I can handle adding Docker support. The first way and easiest way, as I mentioned, let's start with the easy way, is I can open my solution file, which I have open, and you can see that I already have this Docker file up. And it's very simple. It's 7 lines, arguably only 4 because the top 2 are commented out. But I can go over to my actual web application, right-click on it, click Add, and then from here, I can choose to add just Docker support or container orchestration support. And from there, I've already added it, so I'm going to get an error right now. But from there, you would be able to then manipulate your Docker file. So I could make changes to this, or I could just run it. The cool thing is once you add that support, Visual Studio 2019 will actually start building your Docker file for you. That's any of the log information, the output you see down at the bottom here. And then on top of that, if I scroll up, you're also given a Docker Compose file, which is a cool way to stand up services locally on your system. So you can see it's going to use an image that's using an environment variable that's going to reference whatever Docker registry. A registry is going to be kind of like a folder or a collection of where you put the images that you built. And the images are what you're ultimately running inside a container. You have your build context, which is the working directory of where your application code lives. And then you have the location path for where that Docker file lives. And all of these files are given to you for you. And the benefit is you could even go up to, for example, debug and start debugging your application right from within Visual Studio Code, right from within a Docker container. But the reason how come I said that there's an easy way and a hard way is right off the bat, this will work. This will work just fine. And your build step happens outside of this container. But you also have to consider the size of your container. So right now, our application is ASP.NET 4.6 or 4.7. Running this inside a container, inside this Docker file, which let me go back to that file right there, is just under 10 gigabytes worth of a file. So we've definitely made it smaller than a virtual machine, but it's still quite insanely large. On top of that, we don't have any way to pass in our connection string, which we need to connect to our now cloud-based SQL Server. So let me show you the next version. The next version is where you get a little bit more specific with building your Docker files. Now you'll notice that I have a from line. This is where I'm setting my base image. This is the base processes that I need. All I need is Windows Server core kernel, and I need the .NET Framework SDK. From there, I set a working directory, I copy some files, and I do the usual commands I would do locally. Now, this is beneficial because rather than needing to have Visual Studio 2019 and ASP.NET 4.8 or 4.6 or whatever installed on my system, the entire building of my solution takes place within the container. And then on line 19 here, I have a second stage. So this is called a multi-stage Docker file. The second stage is what we're actually going to run in our container. So now we're able to make it a little bit smaller. We can set a working directory because all I need is access to IIS, and it also has the .NET runtime. I don't need the SDK at runtime. And then from there, I copy the build solution file, the built components from my previous stage, and I expose the port. And the cool thing is this container is actually an edited container that AI owns, so I control. I can also make sure that it's a little bit smaller, and I can set a PowerShell script, and there'll be a blog post where you can follow along with some of the nitty gritty, but I can set a PowerShell script to run that'll actually allow me to add a connection string to my container without making any code changes whatsoever. Now, let's take a look at what this all looks like. And to do that, I'm going to use something called Portainer. Portainer is an open source tool that runs in a container locally on your system. And it allows you to visualize what you have going on in your Docker environment. You can see I have 2 containers running, one of which is Portainer, and one of which is our Mercury Health application. Now, I also have 9 images, and you can see 9 images alone still take up 60 gigabytes. If you drop down into these images, you'll notice each one is on average anywhere from 4 gigabytes all the way up to 10.7 gigabytes. So this is where I start to think, just because it's easy doesn't mean it's the right solution. Doesn't mean that it's necessarily sustainable. Now, you can take this container, you can take this image and run it in Windows App Service or in Azure container instances. And let me show you what that looks like. I'm going to flip back over to my browser here, and I'm in my on-prem to the cloud resource group. And I want to show you, this is one that I have running in ACI right now. You can see the application, Mercury Health, ACI, Central US, Azure Container. And if we look at the logs for it, from the time it pulled the image to the time it started the application was just under 10 minutes. So this doesn't make it very resilient, and it doesn't make it very reliable to having to start up quickly every time. So, if you have any questions, feel free to jump in, because there's one more thing I want to show you on how you can improve this.
No, I just also, one thing just to clarify what we've seen so far. In full Visual Studio, you can basically right click and say, give me Docker support, and that will work.
Yes.
That'll give you the basics of what you need, but what you're going to end up with is probably not something you want to put in production as is, right?
It's not something that you're going to have a lot of control over, in particular to how you can control environment variables. Now, you can make code changes to that. In ASP.NET 4.7 and above, you have access to the NuGet package config builders, and you can start to refactor your application to support changing environment variables dynamically, to where you won't need that PowerShell script and you won't need maybe the greater level of control. But now you're starting to get into code changes and refactoring. And this is where, at any point in your journey, moving on-prem to the cloud and continuing on with scale, code changes are just a part of the game, right? It's a part of life. And especially now with .NET 5.0, in this particular context of the application, that gives you a lot of control, because now that'll run on any system. So if you're already going to have to make small code changes within your existing app, if you have, and I'm going to show you the size differences that you can get by refactoring over into something that's cross-platform that can take advantage of smaller environments and smaller kernels. I really think that refactoring ultimately to the new standard in any language, whether that be Node, Java, or .NET, is going to be the way to go, so that you can keep your container as small and portable as possible. Because again, just looking at these timestamps, 10 minutes to start up a container and then to have to pull a 5 GB image, that's really time consuming. So one option, let's go over to Visual Studio Code I have here currently running on my Mac. Now, this is the same application, Mercury Health Core, and it's running this time in .NET Core. Now, it's an older version of .NET Core. It's not 5.0, but the concepts are still the same. The Docker file I have is still multi-stage. I have one as an SDK, which is actually going to be just the base image. This is where I start exposing ports and setting a working directory. I have another stage where I'm going to actually do my .NET restore, my .NET build. A third stage, which is kind of intermediate to handle my publishing. And then my final stage, which is going to actually run the application itself. But even with the way that you write your Docker files, even if your code is up to date, you have to be very intentional about where you want to put it, right? The goal is to make the container as small as possible. So if we take a look here at my command line, down at the bottom, you'll see I have 3 images, or what appears to be 3 images. This on-prem to the cloud is just tagged. I can tag it where I'm going to put it, whether I want to put it in Docker Hub or in Azure or in Quay. You can make your prefix or your image name accordingly. But you'll notice that I have 2 tags. I have one that's small and one that's large. The Docker file that you see here, we got a little bit better than the Windows version. We're now down from 4.9 gigs to 1.7 gigs, but that's still quite large. And this is where I challenge people to really, own your base images, make sure that you're using from a trusted repository, and B, consider the kernel that you need. The kernel in Windows case would be, again, using Server Core or Nano Server. In Linux, you could use a Debian-based image or an Alpine-based image. So for example, if I switch this over to something like this, and I switch even my build stage over to Alpine, and I save that, this now built and compiled gives me this small image, which is just under 200 megabytes. So if you think of the journey that we went through, that default Docker file that Visual Studio 2019 gave us was just under 10 gigs. and slowly making changes where we start adding in, we're very intentional about where we want our code to run and the processes that's needed. And then we invest the time into refactoring. We've gone from 8.5 gigs, again, just under 10, all the way over to now we're under 200 megabytes. So what that looks like now, again, still running this over in Azure, is now you take a look at the logs, you take a look at this Mercury Health Core ACI image, and it ran in less than 60 seconds.
Yeah.
So it's a lot more
from
powerful.
a DevOps
And
perspective, yeah, that's huge.
absolutely. And just to show you one more thing. So if you're wondering how I created these container instances to use those images, the cool thing from within Visual Studio 2019 is I can actually push my image right up from within that program. I can push it up from the command line. So if you're new to Docker, there's a whole wealth of commands that are designed to be very native. So you have Docker pull to grab an image, or Docker push to push an image. So I've already pushed these images over into our Azure Container Registry. And if I wanted to use those images, I would simply go and create a new resource by clicking, there's a plus sign right here that you can do either within a resource group or within your subscription. And then from there, you can choose container instances, which is great for short-term applications, APIs, and batch jobs. Or for long-running applications, I really recommend running it in app service with container support, be it Windows or be it Linux. You would go to web app for containers, and you just follow the on-screen prompts. You would give it a name, you would give it an app service plan. Over into Docker, you could choose if you want a single container, or you can actually do a whole stack. You can choose the image source. So for example, we could do our container registry. You can see I have on-prem to the cloud. I can choose any of the images that I've built here. We can choose our core app and choose my tag. And from there, you would just create that service. It is very simple. But one reason how come I said that I would recommend using Azure Web App over ACI is Azure Web Apps gives you a lot more control. I can change the container image. I can change the registry I'm pulling from. B, I can also take advantage of deployment slots, which is going to be really helpful as we progress through this journey, as we take a look at different environments and DevOps best practices, and we were able to swap our dev and prod or canary slots. And then we also get automatic access to TLS and SSL without any code changes on our backend. So to show you, here is our application deployed within a Windows container right now in Azure. And it's fully secured and backed by a certificate that I didn't have to provision, I didn't have to create. Whereas if we look at our ACI instance or Azure Container instance, it is an unsecured running container.
Right. Wow. Yeah. Another bonus kind of that you get just of choosing the right options, I guess.
Choosing the right, and there's no wrong option. As you start this journey, sometimes I recommend just playing with Azure Container instances to test your container, especially since it's billable per second. It's kind of like Docker run, again, in the cloud, the same way I would run Docker run locally. I'm going to get access to that also up in Azure.
Wow. So that's a pretty cool journey. You're able to put the application kind of as is into a container, like right from Visual Studio, just with the kind of a menu options.
Yep.
But as you go towards a production, more cloud native scenario, you really want to tweak what you're doing there and choose the right options and things like that.
Absolutely. And just to show you, this is the application running on Windows in a container. And if I click things like exercises or nutrition, that's information that's hosted in the database, it's a little slow sometimes, but that will actually make that connection because we were able to use that PowerShell script that I mentioned. And again, there'll be a blog post recapping all of this, but we were able to use that PowerShell script to actually replace the connection string. And while that's loading, you can actually see that in our running container. Again, Portainer is really great if you're just now getting started with containers, but you can see that we have an environment variable right down here for our connection string. And so that's what's added into our container itself. And just right there on the back, flipping back over to that tab, that was able to make that connection accordingly. And one more thing to note, because I'm making this locally, I did have to make sure that I temporarily granted access to for my IP to have access to that database. I don't recommend doing that, obviously, in a production scenario.
Yep, of course. Wow. So that's really cool. And that's kind of a really nice way of pitching you don't have to change much to get it running, but if you want to go on this journey, you really need to think about what you're choosing and what you're doing with those containers.
Absolutely. And I think that one of the biggest things I hear from people is when they're getting started with containers, you have two types of people. You have one that's very much, I don't want to deal with containers. I have all my legacy Windows applications and I don't want to refactor anything. And then you have other people that very much like containers, but don't like Windows containers. And people in the first group don't understand why they don't like Windows containers. And there's nothing wrong with Windows containers or Linux containers, but you do have to consider the pros and cons. The pros of Linux containers offering you that smaller size, the smaller your image is, the smaller your attack surface is, the more portable it is, the faster it is, the more resilient. And then on the Windows side, people also have to consider that it is a really big pain point. Not everyone can refactor their code immediately tomorrow. And so this is really kind of a happy medium, but I also hope that this can help visualize why it can pay dividends to ultimately refactor your code and get your application isolated as small as possible with only the absolute processes that's needed.
Yeah, absolutely. Oh, look, thank you so much for joining us and walking us through this. I think we're getting much closer to covering everything we want to cover in this series. And so next time, I think we're looking at security, which will be the next little thing that we need to consider as we're going through. So thanks so much, Jessica, and everybody who is watching, and we'll see you next time on the DevOps Lab.
Thank you, Damien. Thanks, everyone.